All right, welcome to Lesson 6, Video Reflection Notes. So what we're going to be talking about today is how to reflect points and shapes on a coordinate plane. So we can use what we know about number lines and opposites to compare locations on coordinate planes. Consider the number line in the coordinate plane below. So if we recall, a number line shows that -4 and +4 are opposites because -4 and +4 are both 4 spaces away from 0 on a number line. So these two are opposites. Well, if we look here on a coordinate plane, if we've got the coordinate point -4, 0, and we've got the coordinate point +4, 0, we can say that these two are opposites because they're both 4 units away from the origin or the y-axis on our coordinate plane. So the coordinate plane shows that -4, 0 and +4, 0 are the same distance from the y-axis in opposite directions. So they reflect across the y-axis. Notice that the y-coordinates did not change, so 0 and 0 didn't change, only the x-coordinates did. And that these x-coordinates are opposites of each other, -4 and +4, okay? So now let's talk about how do we reflect across the x-axis. Well, when we reflect across the x-axis, we're going to keep the x-coordinate the same, and we're just going to use the opposite y-coordinate. Now, this is the opposite when we are reflecting across the y-axis because here we're going to keep the y-coordinate the same, and we're going to use the opposite x-coordinate. So let's go ahead and go through an example. The first example says graph the point A at +2, -4, then graph its reflection across the y-axis, across the x-axis, my apologies. So first we're gonna graph the point A at +2, -4. So I'm gonna start at my origin, I'm gonna go to the right 2, and then I'm gonna go down 4. I'm going to place a point right there, and I'm going to label it with a letter A. Now, next, I'm going to graph the reflection across the x-axis. So what I want to do is take this point and flip it over the x-axis, which, if I go back up here to my notes to reflect across the x-axis, I'm going to keep the same x-coordinate. So my x-coordinate is going to stay +2. But I'm going to use the opposite of my y-coordinate. So my y-coordinate is going to be +4. And I can go ahead and graph +2, +4, put a point right there. Now, I need to label this second point, this reflected point. And the way I label it is actually with the same letter as the original point, but I add an apostrophe after the letter. And we refer to this as A prime. So A prime represents the reflection of original point A. Let's try the next example. So the next example asks us to reflect point B at -1.5 and +3, and then graph the reflected across the y-axis. So first I'm going to graph point B at -1, so I'm going to go to the left -1, and then I'm going to go up 3. Put a plot right there, and I'm going to label it B. Now next, I'm going to reflect that point over the y-axis. Remember that when I reflect over the y-axis, I keep the y-coordinate the same. So my y-coordinate is still going to be +3, but my x-coordinate is going to change to the opposite. So the opposite of -1.5 is +1.5. And I know that my new point is going to be 1.5, 3. So I'm going to find that on my coordinate plane, plot a point right there. And then again, I need to label this reflection point or this opposite point. So I'm going to label it B with an apostrophe, which stands for B prime, which shows you that this is the reflected point of our original B. So let's go through and try a couple, remembering our rules that we had up here at the top of our paper. All right, name the ordered pair that is reflected of each point across the x-axis. So we can use the coordinate plane over here if you need to, or you can use this rule that we learned up here at the top. So it says that we're reflecting across the x-axis. So first thing I'm going to do is plot my point, +1, -4. And I'm trying to plot that across the x-axis. So I'm moving it across the x-axis, which means that my x is going to stay the same and my y is going to change to the opposite. So my y is going to change to +4. So I'm left with the point +1, +4. And that point would look like it was right up there. Okay? Now the next one, it says -2, +5. So again, you can use either your rule up here or you can use your coordinate plane. I'm just going to use the rule for this one. So it says keep the x coordinate the same. So I'm going to keep -2. And then I'm going to use the opposite of the y coordinate. So instead of +5, I'm going to use -5. And let's go ahead and try that last one. It says -3, 1. Again, I'm reflecting over the x-axis, so I'm going to keep the x the same. I'm going to change to the opposite of the y, so instead of -1, I'm going to have +1. And I have a reflected point at -3, 1. Now, we're going to do the same thing, except we're going to reflect over the y-axis. Remember that when we reflect over the y-axis, we keep the y coordinate the same and use the opposite of the x coordinate. So I will go ahead and plot this first point on my coordinate plane, +1, -4. And I want to reflect over the y-axis, so that point is going to be right here at -1, -4. Again, we notice that the y stays the same and the x changes to its opposite. Next one is -2, +5. So here we're going to keep the y the same and we're going to change the -2 to a +2. And our last one that we're going to go over is -3, -1. So we're going to keep the y, -1. And then we're going to change -3 to a +3. And we have our reflected point. All right, let's try a story problem. Now this is going to bridge us into how to reflect shapes on our coordinate plane. So it says Amelia is drawing a map of the park. She graphs the entrance at +2, -3. So we know this is going to be the entrance. Let's go ahead and graph it. We go over +2, down 3, create a point right there. She then reflects the point of +2, -3 across the y-axis. So we know we want to take this point and flip it across the y-axis. Well, to move it across the y-axis, my y stays the same, so I've got -3. And my x changes to the opposite, so instead of +2, I plot it at -2, -3. Y stays the same, x is the opposite. Plot a point right there. Amelia then reflects this new point, so our green point, across the x-axis. So now we're taking this green point and we're moving it across the x-axis. What is the final figure? So when we reflect this new point across the x-axis, we're going to keep the x the same of -2, and we're going to use the opposite of our y. So instead of -3, it's going to be +3. So our new point, or our third point, is -2, +3. Okay? Then it asks us what figure is graphed on the map. So this is the shape of our park. We can go ahead and connect all of our lines. And we know then that our shape is a triangle. All right, let's go ahead and go through the next one. So now we're actually reflecting shapes on our coordinate plane. So given the image of the rectangle, TUVW, so TUVW, after a reflection over the x-axis. So we need to graph this over the x-axis. So we're going to be taking it from the first quadrant and moving it to the fourth quadrant. In order to do this, the easiest way is to figure out what are our ordered pairs for each of our corner points of our figure. So if we just look at T, the point T, we can see that the ordered pair here is +1, +3. And I'm reflecting it over the x-axis. So what I'm going to do is I'm going to keep the x the same and use the opposite of the y. So I want it to be +1, -3, which that point is going to land me right here. And I want to label this point then T prime to show that it's the opposite or the reflected of original point T. Okay, now we can go ahead and graph the U point, which is right over here. Again, find the ordered pair. So I'm going to take 9, +3. And I want to graph the opposite over the x-axis. So I'm going to keep my x the same, 9, and use the opposite of the y, so -3. Plot a point right there. And I'm going to label this point U prime, so U with an apostrophe. Next, I'm going to, let me get a different colored pen. I'm going to do point U, or point V up here. Point V is at +9, +5. So I'm going to keep the x the same, and I'm going to plot this at +9, -5. Right there. +9, -5. And I'm going to label this V prime, or V with an apostrophe next to it. And my last point is going to be the reflection of W. Well, W is at 1, 5. So I'm going to plot this at 1, -5. And I'm going to label that W prime, or W apostrophe. And my last step is just to connect the lines together to show my reflected shape. All right, what I'm going to encourage you to do now is to try the next one on your own. So if you'd like to pause the video, try it, and then you can come back and check your work against mine. Or if you still feel a little shaky and you want to go through it with me, then just continue the video now. All right, so it says graph the image of the square BCDE over or after a reflection over the y-axis. So I'm trying to take this picture and reflect it over the y. So first I'm going to start with letter B, just to go in order. Letter B is at the point -10, -5. So to go over the y-axis, I'm going to keep the y the same, -5, and I'm going to plot that point at +10. So +10, -5, and this is B prime. Next, I'm going to do the letter C. The order that you go in really doesn't matter. I'm just going in the order listed up here, but again, it shouldn't matter. C is at -3, -5. So I'm going to plot this one at +3, -5. And this is going to give me C prime. Next, I'll do point D, which is at -3, +2. So if I reflect it over the y-axis, it's going to be at +3, +2. And this will be D prime. And my last point is going to be point E, which is originally at -10, +2. So my reflected point then would be +10, +2. And I will label that as E prime. Last step is just to connect your points so that you have your square and it's reflected from its original. The last part that we're just going to go over is distance review. So this is what we were going over last Thursday and Friday. Or over the last couple days, I'm sorry. The distance review, if you are not given a coordinate plane, you can find the distance between two ordered pairs by finding their absolute value or by drawing a number line. So we went over this last week that if our points are in two different quadrants, which if you think -5, +7 would be up here in our second quadrant, and +4, +7 would be in our first quadrant, so those are going to be in two different quadrants. We can go ahead and just find their absolute value of -5 and add the absolute value of 4. Well, absolute value of -5 is 5 plus 4 equals a distance of 9. And here's another one, +3, 4 and +3, 9. Both of these are going to be located in that first quadrant. So in this case, all we need to do is subtract 9 minus 4, and that gives us a final distance of 5. Again, if these methods do not work for you, you can draw a number line or you can use your coordinate planes as well to figure out the distance. All right, please see your teacher if you have any questions, and go ahead and move on to the next activity.